In section 3, we learned about scale factor, that value K that we use to proportionally blow up or shrink a figure. Now that we were dealing with one dimension. We were dealing with length or a height or a width, and we could also apply that to the perimeter of figures. What we're going to talk about in this unit is what happens when we start comparing the surface areas and the volumes of figure when it comes to that scale factor. So let's take a look at some of these rules. So the ratio of side lengths in this picture, I can pick either set, and so if I compare these two corresponding sides, K would be equal to 40 over 60, which reduces to 4/6. Cancel a 10, and if I take out a 2, my scale factor is 2/3. The ratio of the perimeters, if I find perimeter, add up all, we're going to call this figure 1, and we'll call this figure 2. The perimeter of figure 1 would be equal to 30 plus 40 plus 30 plus 40, which ends up being 140. And if I find the figure of perimeter 2, that is 45 plus 60 plus 45 plus 60, and that ends up being 210. So when I look at the ratio of those, I end up with 140 over 210, which reduces to 14 over 21, which reduces to 2/3. So I'd already kind of previewed that perimeter is K because we're talking about one dimension. The label on perimeter is units, and so I only have a one dimension, so those are going to vary by a factor of 2/3. 2 units of the first figure for every 3 units of the second figure. Now when we go to area, something interesting happens. Remember, the unit on area is units squared. That's a hint. So let's calculate the area of figure 1. Area of a rectangle is length times width, and so I end up with an area of 1200. The area of figure 2, length times width, I end up with an area of 2700. So when I compare those in a ratio of 1200 over 2700, that reduces to 12 over 27, which is going to reduce to 4 over 9. If I do some comparing, 2 and 4 are related, and 3 and 9 are related. So the ratio of the sides and perimeters, they are the same. Now the sides and the area, the ratio of the sides were 2/3. Ratio of area is 4/9. How could I turn that into? And what happens is if I square this, my hint, units squared, I get the ratio of area. So our conclusion is that the ratio of area of 2 areas is K squared. Now, why might this be? Let's look at a generic length and width. So my area is length times width. If I have a scale factor of K, then this is KL and KW. Multiply each, figure 1, figure 2. My area of figure 2 then is KL times KW. So it's K squared LW. How much bigger is it? It's K squared bigger because I've changed 2 dimensions by a factor of K. When I multiply them, I get K squared. That's why that works out that way. If I look at a prism, so our scale factor, any two sides compared, k is 5 over 25, which reduces to 1/5. Now if I look at the surface area of each one, and I calculate all of that out, so my surface area of A is going to be 2 times 5 times 16 plus 2 times 16 times 3 plus 2 times 5 times 3. There are 6 faces, 2 ends here and there, the top and the bottom, the front and the back that are all the same. So 2 times those rectangles. There are 6 rectangles. All of that is going to work out to 286 units squared. If I find the surface area of B, that would be 2 times 25 times 80 plus 2 times 80 times 15 plus 2 times 25 times 15 to get all those different combinations. And when I multiply and add all of that, I end up with a surface area of 7150. From the last example, area should vary by a factor of k squared. So I should get 1 over 25. If I square this, I should get 1 over 25. So if you take 286 over 7150 and you reduce it with your calculator, you get 1 over 25. Now volume. Volume is a 3-dimensional calculation because we take length times width times height. We talk about it as units cubed. There's your hint. If you are suspecting that it's going to be k cubed, let's see if you're right. So the volume of figure A is 5 times 16 times 3, length times width times height, which is 240. Volume of figure B is 25 times 80 times 15, which is 30,000. And when I put those in a ratio, 240 over 30,000, and you reduce your fraction, you're going to get 1 over 125. And 1 over 125 is 1 over 5 cubed. It is k cubed. So our conclusions are one-dimensional things like length, perimeter, circumference, height. Anything with a label of units will compare as k. Anything with 2 dimensions in the calculation, area, surface area, anything with units squared will vary by a factor of k squared, and anything with 3 dimensions, volume, units cubed, will vary by a factor of k cubed. As a side note, I want you to think about how these numbers are related. If I know k, I can go straight to k squared by squaring, and I can go straight to k cubed by cubing. If I know k squared, I can go straight to k by taking the square root. I cannot go straight to k cubed. I have to take it out to k by square rooting, then cube it. If I am at k cubed, I can go straight to k by taking the cube root. Make sure you know how to use your calculator. But I cannot go straight from k cubed to k squared. So I have to cube root out to k and then square it to get k squared. So this is important to think about as we move into the next video.